Great. Okay, so very quickly for the beginning, let me just say a little bit about me, who I am, why you would have any interest in listening to me in particular talk about this topic. I studied astrophysics for undergraduate and master's degree, and I have been actively working in the space sector for approximately 8 years now since finishing my education. Here's a broad overview of my academic and professional qualifications and any other related qualifications outside of the realm of academia and professional workforce where I've been paid and hired to do work. I am from Ireland and I have a particular interest in space since I was, well, pretty young, but decided to pursue the area of astronomical research or space mission control or participation for exploration. So this is an area that is very interesting to me and that I really enjoy to have conversations with people about. As I say, it's the backbone of my education, but even since then, I have always stayed in contact with this field in one way or another, even when I haven't been working in the space sector for some time. So to quickly run through the background, even though you can read it, just to go over it quickly and spare you the trouble. I mentioned my bachelor's and master's degrees. I did my thesis in radiation shielding for the European concept of the lunar habitat. That was with the Spaceship EAC team in the Astronaut Center in Cologne. I was also a national trainee at the European Space Astronomy Center for 2 years, where I worked with the Gaia Space Operations Center. And that was thanks to funding from the Irish government. I have worked as a research and development project manager for a biofuels manufacturing company, and currently I am a STRATOS flight controller for the Columbus module on the ISS. We'll get into a bit more about what that means shortly, but just to quickly go over some of the other experience and qualifications that I have that led me to where I am today. I am a long-term member of the Austrian Space Forum since 2018. Where I have participated so far in 2 analog missions, both Mars simulations, and I've been a member of flight planning, flight control, and most recently, I am a flight director for the IRVF. So I have spent a lot of time there. I am now directly involved in recruitment and training for new members of the IRVF. So if anyone has questions about other related topics, outside of just the professional path, I'm happy to discuss those later as well. I have also been a leader and coordinator for the International Astronomical Workshop, or the International Workshop for Astronomy, which runs the International Astronomical Youth Camp, which is an annual summer camp for a few weeks for everyone aged 16 to 24. Who has any kind of passing interest in space. So you don't have to be an astronomer or engineer, somebody who's planning on doing this as a career. If you love space, if you think it's cool and fascinating, that's a great place to be. You meet other like-minded people from all kinds of backgrounds and from all around the world. So that is an experience that was quite formative for me and who I have become. Something that I can highly recommend, not necessarily that you have to do this camp, but those kinds of experiences are extremely valuable. And lastly, I was an analog astronaut for a 2-week medical isolation mission, which was conducted in the Lunaris habitat in Poland, where I was the medical officer despite having no medical background, where that was simply the name of the role that I was assigned, but really it was more of a science position where I was in charge of conducting the medical experiments, collecting that data and delivering it to the actual medical personnel who were going to then study that information. So I was just responsible as a scientist for conducting that research on their behalf and collecting and storing all the data correctly. So getting into STRATOS. What is STRATOS? What do we do? And what is this ISS flight control jig all about? We basically divide the STRATOS team into 2 core responsibilities. This is for historical reasons I can discuss a little bit after, but we divide STRATOS and our responsibilities into systems and DMS comms. These are the two specialist streams for our team. Systems includes 3 of the Columbus subsystems, and DMS comms the other 2, which are in the title. Systems covers the electrical power distribution system, environmental control and life support system, and the thermal control system. And these are all classic systems that you expect to find in any spacecraft, any space mission, especially ones that are going to host any living creatures, especially human crew. And likewise, DMS comms covers data management system, the DMS system, and the communication system. Excuse me, I'm coming down with a cough, so unfortunately I'll be probably coughing quite a bit going through this presentation. But these names are fairly self-explanatory, so we can go into a little bit more about the module itself and how we actually go about managing these things. So overall, from NASA, who was the prime partner with Roscosmos in the whole ISS program, that we have then since become junior partners too. So the prime partners are NASA and Roscosmos, ESA, JAXA, CSA. We are all partnered with NASA as international partners to the station, and they defined these principles of mission control by which we try to conduct our work. Discipline is about being able to follow instruction as well as to lead and to know the role that you need to fill at any time and to do so to the best of your ability. Competence is simply that there is in this environment no room for error or for hesitance, so that we come into our work with the next point as well, confidence, knowing that what we are going to do, we are going to do it well. We are going to dedicate ourselves entirely to being fully prepared and doing the best work that can be done under the circumstances provided to us. Responsibility is, of course, connected to these as well, as realizing that the responsibility that we carry is quite heavy, but also that when we are working, it is hours and hours alone, that we cannot shrug off this responsibility or expect others to fulfill it for us. So we do what we do, and we take full responsibility for the outcomes of that, good, bad, and otherwise. That we must be tough and take a stand on issues that matter. For example, when safety comes into play, that we stand for what we believe in and that we make sure to work through difficult situations and maintain composure and keep working even when things aren't going the way that we expected or that they should have done. We are, of course, a team in Europe, but also as the entire ISS program as a whole. We are all one team working together across the world. So coordination and cooperation between all of our different positions, all of our different sites is an essential aspect of what we do and how we work. And of course, being vigilant, again, tying back to multiple of these other points, but that we are always paying attention to every detail, and especially that we are ready and anticipating everything that could go wrong in order to make sure that we are always prepared and foreseeing and avoiding as much of the difficulties as we might be able to do. Whoa, sorry. So for anyone who's not already fully familiar with the Columbus module, it is at the forward position of the International Space Station. So we define the coordinates in the International Space Station by the direction that it orbits around the world. So forward is the direction of travel. Aft, or the back of the station, is the Russian segment, which is in the direction that the station is coming from. And then we use nautical terms to define the port and starboard, which would otherwise be the left and right of the station. So that gives us also then the freedom to define overhead and deck, or in some cases, zenith and nadir for the all the different directions that you might direct people in an environment where up and down don't strictly have any meaning anymore, depending on what way the astronauts are oriented in the station. Up from their perspective is simply which direction their head is in, and that really has no relation to the rest of the station or anything that we might be asking them for. So that's why we have these defined terms to help us to accurately say exactly where something is in the station, where somebody should go, or where an experiment is to take place. And here on the left, you have a view, let's say an artist's rendering of what the inside of Columbus, the outside of Columbus is like, attached to the forward starboard of the station, connected to the US Node 2. And you see in this picture some examples of the external payloads that Columbus supports. So these are experiments that are connected to Columbus and supported by the STRATOS flight controllers that are outside of the station and exposed to the vacuum. And we have a total of 12, well, 16 ISPR positions that are filled with experiments. So the ISPR is International Standard Payload Rack, I believe, if I recall correctly. And so these are the spaces where experiments can be installed inside of the Columbus module and where all of the science happens, but of course also where all of the basic equipment that helps us to realize the mission, where the storage for the crew to keep all of the experiment equipment and their tools goes, and also where we can share and host some space from NASA and other international partners who also can do their science in Columbus. So here you can see that in a little bit more detail. You can see the exploded view of the overhead, forward, aft, starboard deck and port of the station. And we define exact positions based on which rack. So it's subdivided by rack. And we can easily direct crew to exactly the right place. And when I say crew, of course, I mean the astronauts. But this is also how we are able to define very specifically what it is that we are trying to do as ground controllers, or flight controllers in this case, when we are commanding the station and we specify that a specific rack is to be turned on or any other action that we might be performing on it, then we will specify that by the rack position, and that is how we uniquely identify them. But it also helps us to spatially break down the station to accurately communicate with the astronauts so that we understand one another clearly. We can describe the starboard and port cones, which are the ends of the station or of the module. The port cone is the one that is connected to Node 2 and to the rest of the International Space Station. The starboard cone hosts the external payloads and generally a significant amount of storage space, as well as our interfaces for some of our subsystems. And you can also see a rough overview, which is no longer up to date or fully accurate, but you can see an overview of some of the racks that are used by ESA, some that are used by NASA. In general, this changes over time, but we always are hosting experiments from the other international partners as well in Columbus, including from Roscosmos. So there are also experiments by the Russians that are conducted in Columbus. So it is a truly international and collaborative endeavor, as the rest of the station is. You might ask yourself how the station or how the module is operated, how we are able to power it and provide the services that we do. And of course, all of those resources are generated and provided by the station itself. So we depend on NASA and the rest of the US orbital segment to provide the resources that are used by the Columbus module. And that's simply by design of the station and how it was always intended to work, even before the international partners such as ESA and JAXA became parties to the station. So typical work by the STRATOS flight controllers. We went over what subsystems we are responsible for, but what does that really translate to? It can be from something as basic as the crew are performing a medical experiment and they need to remove their clothes. And so we might increase the cabin temperature for them so that they will be more comfortable while they're performing those experiments, unless it is for some reason required that they be cold during the experiment. We support turning on and off the cameras on station so that we can see what the crew are doing and we can help help them with their work. As well as when you've seen these video feeds of astronauts giving conferences from space and talking to people on the radio from schools or any other occasion you may have seen the astronauts talking in space, that very often will be in Columbus or in the GEM, which is the JAXA module on the opposite side of Node 2. So you will maybe already be somewhat familiar with the inside view of Columbus because you may have seen it already in some of those videos, and we will often be supporting with those video assets. And of course, crew help us with actually pointing the cameras and so on with the setup. So we will support all kinds of crew activities, including their science activities, both involving crew and without them. So a lot of the science can be commanded from the ground. In general, the STRATOS flight controllers are not involved directly with the science. We simply facilitate it as the operators of the subsystems. So if an experiment needs to be turned on, then we turn it on. We make sure that it has cooling and gas resources or anything else that we are able to provide. We enable that, we activate the systems. But then it is up to other positions, the USOCs and science operators, to actually conduct the experiments. So there is a significant subdivision of responsibilities and who does what. Excuse me. And we collaborate very closely on all of these activities. So it's not that I get to just do STRATOS things and worry only about my work, but when and how I do things will vary a lot depending on how crew are working and what the needs of the remote science operators might be. So sometimes we'll do things much faster, much slower, we'll encounter problems and we'll help to fix them. We also support with planning, looking ahead at the forward timeline, the plan of what we're going to do tomorrow, what we're going to do next week, what we're going to do next month. So we, both offline and online, being on the console or in the office, we help with reviewing the plans of what is going to come, and especially activities that we perform and that we support or that are connected to us, such as crew activities that require us to enable particular hardware or to prepare particular things in advance for them. Those are our responsibility to review and make sure that we will be able to properly support them as they have been planned. We also send data to and from the station. Some data can be transmitted directly by science users, but oftentimes, especially if there's software required on the station, then that is the responsibility of STRATOS and sometimes of some of our partners to upload files, retrieve files and logs to investigate problems that might occur, and to install new software both for experiments and for our support hardware, such as the laptops that we use for controlling some of those experiments, as well as the station itself. There are laptops that are used for commanding and controlling the US orbital segment, as well as Columbus itself. And those are not often used for those command functions because they exist so that the crew are also able to perform commanding. But since we are working on the ground and doing this for them so that we can optimize their time and let the crew focus on the things that only they are in a position to do, we try to do as much of that commanding as possible in advance or at the same time as they are working so that they don't need to worry about it. Of course, one of the things that might be most obvious is that we oversee the systems of Columbus and we make sure that everything is working correctly and safely, most of all. We have a subdivision between vital systems and nominal systems within Columbus. So vital systems have a much higher level of oversight and they are connected to more automatic responses. So if anything is going wrong in the vital system, then we will have a rapid response to make sure that the module remains safe, especially for the crew, but also for our hardware and for our science, so that we can support things as well as possible, and that our science partners will also be protected. So we do everything possible that we can fix problems without interfering with science when we're able to do so. But of course, as in any expeditionary environment, we have priorities. So sometimes science has to be sacrificed in order to maintain safety for the station and the crew. We perform regular maintenance activities. So as in any system, there's degradation or maintenance work that needs to be done on a regular basis, some more often than others. But we perform software maintenance for the laptops. We perform regular retrievals of data from the station to check for any errors that might have gone unnoticed. Excuse me. We also uplink security patches because the station isn't and shouldn't be connected directly to the internet. So when software updates are required, then we are part of the process for uploading and installing software for the station, and especially those security critical software patches. We also, as STRATOS, are one of the prime interfaces with other centers, so both with the European science users, but also with the NASA positions and the NASA flight controllers. STRATOS is one of the main interface points between the European flight control room and the other flight control rooms, and we coordinate our resources and our activities with our partners who are responsible for the same subsystems. And so if well, yes, and let me finish going through this, and then I can talk a little bit more about the counterparts that we have in the other station, in the other parts of the station and the other control centers, as well as the other positions that exist within the European control room. So sometimes things go wrong, as in any environment and any workplace. And it is our responsibility to be first responders to things that go wrong. We are, many of us, engineers or scientists by trade, but it is not the responsibility of STRATOS to fix every problem that occurs, but simply to make sure that we keep the system safe. So if it's necessary for us to stop at some point because the system has not been completely corrected or fixed, but it is now in a safe state, that is the extent of the STRATOS responsibility in real-time operations. We just need to make sure to keep the system safe. If we are able to fully recover it, and especially if we have procedures to do so, then we will. But very often things go wrong that are unexpected or not fully understood. And then we have support from other engineering sites, the people who helped build and design the systems that are on board. And they help us to investigate things that go wrong and to come up with a plan for fixing it when that is necessary, when something complex or important has gone wrong. And most importantly, and perhaps most obviously, STRATOS is responsible for emergency response. We can maybe address in the questions afterwards if you want to know more about the emergencies themselves, but very broadly, the main emergencies that can occur on the station are a rapid depressurization. So for some reason, the cabin is losing atmosphere and maybe part of the station or only an individual module might need to be isolated to protect the crew. Also, a fire emergency, which is perhaps the most obvious and the most well-known in the space environment. So in a fire emergency, we are responsible for trying to interrupt power flow and to stop the spread of those events. And perhaps least well known, there are also some toxic elements used for certain experiments or also for part of our cooling system. So the other critical emergency is an ammonia leak on station, and crew will respond very rapidly and isolate themselves from the station in order to protect themselves from such a leak. You see a list of the offline work that we do. So we do a lot of office work, also largely in the effort to coordinate and prepare all of our activities very thoroughly and in detail in advance, and of course also to train ourselves and new members of our team. But I won't go through that in too much detail for now. We can come back to it in questions if you want. So very quickly, who are the other positions that support in ESA flight control or in European flight control room? Generally, this is the layout of our main control room, the other positions being Eurocom, who's responsible for communicating with the station on behalf of Munich, specifically as our call sign, even though Eurocom are usually in the astronaut center in Cologne. We have the Columbus flight director, Cole Flight, who sits right behind the STRATOS console, which you can see accurately represented is significantly larger than most of the consoles because we have a lot of screens, so we can monitor a lot of things happening all at once. Cosmo is a position that is based in Turin in Italy, and they support inventory and stowage. So if we need to know where a specific screwdriver is in the Columbus module, they are the team that know exactly where every little piece of equipment is, and they can quickly tell us how to find it so that crew don't waste time looking through boxes and trying to find things that are missing, or if we have specific equipment for an experiment, that we can directly find that and get to work. Epic or Comet is the planning team. They are Epic when they are generally operating as planners, and Comet when they sit on console and are in the control room directly coordinating real-time planning and operations. And in the background, we also have the GSOC GC, the ground control team, who help make sure that all of our ground systems are working and operating in a good manner. So if I lose connection to the NASA link, or I lose connection to some of my systems that I use for commanding the station or for sending files to the station, these ground controllers are the ones who help to make sure that everything is healthy on the ground and that I can still do my work. We, of course, still have many international partners, people who we are collaborating with and that I have mentioned. I have gone through the names already, but here you can see the logos. And of course, there are other partners who have worked with us, but these are the official cohort of the station, and other agencies have participated and sent people to the station, sent science experiments to the station. And in the future, for future projects like Gateway and the Artemis program, it is, of course, hoped that more agencies will join and that we will have an increasingly global collaboration in the space. Other operators for Europe, other science operations for the most part, the USOCs. Cadmos is connected to CNES from France. BUSOC is based in Belgium. Musk is based at the Deutsche Luftraumfahrtfahrt, the German aerospace agency, in their center in Cologne, next to the astronaut center. Biotech is based in Switzerland. ECOS is based in the astronaut center, and they support some science, or rather some medical related science for the most part. Bartolomeo is run by Airbus, and Bartolomeo is an external commercial platform. So this is one of the platforms on the outside of Columbus, which hosts guest experiments. So it is an extra extension for us to be able to put more science on the station, and that anybody can pay to put more experiments on the station and to get more out of it. EDRS is the European satellite network that we use for our private comlink. So we generally are using NASA assets for S-band and Ku-band communication to and from the station, but we also have a Ka-band antenna on Columbus that can communicate with this IDRIS satellite network, so that we have a direct means of communication as well, should we need it. And this is mostly used for high volume science data downlink. And we also have the engineering teams, which are based in Italy and Germany, with the Italian Space Agency and with Airbus. There are a wide array of companies. I personally work for GMB, but within the control room, we don't really pay much heed to who is working for who. We're all one team collaborating, so who exactly is paying your check at the end of the day isn't a big concern for us. So how do you get involved in this kind of work, and who does this kind of work? Well, we unfortunately have pretty high turnover in this line of work. It's very difficult to work such long hours and to work weekends, nights, to sometimes have to work 12-hour shifts because somebody got sick and couldn't make it to take up their turn. So it is a very demanding work environment. It's very stressful. We're quite short-handed. There's a lot of work to be done, and there's never enough people to do it. So we are always working hard, and people burn out, or thanks to how well this experience is viewed, they often move on to other more relaxed and higher paid positions with more responsibility, safe in the knowledge that they have been through this experience and they know space operations really, really well and from many different points of view, as many times other flight controllers, especially the NASA controllers, are much more specialized than we are, but we are the taskmasters who can do it all. So the STRATOS flight controller is the one technical position for all of Europe, and we handle every subsystem, while NASA has a dedicated position for every individual subsystem. And who can do this? Well, and pretty much anybody with a STEM background and at least a master's level education is welcome to apply. Those are essentially the only real requirements, as nobody comes in prepared for what this job is. You will learn it by doing it. It takes, well, it used to take about a year, and now before you will be sitting on console alone and working solo as STRATOS, you will be training for at least half a year, which includes lessons in the Astronaut Center, simulations, and a few different levels of theoretical examination and certification before you become a fully certified STRATOS and you start doing this work on your own. But of course, it is a never-ending learning process. I've been doing this work for about 2.5 years now, and I am still always learning something new. And there's always more things to learn and to examine and to get better at. So this is an environment where you are always growing and always facing new challenges. So it's really not that hard. We have not that hard to get the opportunity to be involved, and the basic requirements to qualify are not very high. And we hire generally across the whole flight control team. So for flight, Cold Flight, Epic, and STRATOS being 3 positions whose numbers are linked, there's always the same total number between those positions. We hire 2 to 3 new people twice a year, with training cycles starting in February and September. So there are lots of opportunities to get involved. If you meet the requirements and you are interested, then just keep an eye out on social media or on the companies who contract us, and watch for these opportunities when they come, and we'll be happy to have more people. So yeah, I did mention I would come back to a few topics, but considering the time, I will let you guys ask your questions and decide what you most would like to hear more about. And I think Uri has some pre-prepared questions to help lead the way. So thank you very much. And please, I open the floor to all of you.
Okay, maybe for those who are not on the Teams call, usually we have like comments in the YouTube, but this seems to be not working. So please, if you have any questions, I have opened the Slido, and if you enter this pin, you can ask a question, even those people who are watching. So I will leave it for some time. 163-3743. Okay, so if someone has a question, please raise your hand, and I will unmute you. Okay, if no questions. Okay.
There we go.
Can you hear me?
Yes.
I wanted to ask, what is typically the fraction between online and offline work that you have to do, and how does that distribute through your schedule during the week?
So it actually changes as you evolve through the job. When we are freshly certified, we spend a lot more time on console covering shifts. And as you become more experienced, you take more of the offline responsibilities. You can take the point on coordinating a specific new system that might be in development, or on coordinating our procedures and updating and keeping those up to date with changes on the station or with improvements after we resolve malfunctions and anomalies. So the more experienced you are, the more of those extra responsibilities end up being assigned to you, and you take responsibility for those. And of course, that takes time. So you spend less time on console and more time working in the office on those additional topics. So there's no one straight, simple answer that I can give you for how much time we spend doing one or the other. It depends, and the balance of that will change over time. But as a ballpark figure, when you are freshly certified, you will do approximately 10 shifts in a month. So you'll spend about 80 hours, 90 hours on console in a month when you're newly certified, and the rest of your time will be spent training and working in the office on preparation, timeline reviews, and other work that we need to do behind the scenes to keep things running. It doesn't necessarily sound like a lot, but it really does add up. And of course, we work 24/7. The station is always up there. So we work 3 8-hour shifts with 1 hour margin for handover. So we count 9 hours anytime that we are on console, because we need quite a bit of time to, well, sometimes we need quite a lot of time to explain to oncoming shifts all of the things that might be going on. And especially when things have gone wrong, we need to make sure that they're properly prepared in case they happen again or they get any worse. They need to understand the situation, and we pass on all of that information. We always give a status update of the general state of Columbus when we're handing on to the next shift. So yeah, you start out at approximately 90 hours per month on console, and that will drift down to eventually 0 if you are increment lead. Then you are the representative of our team towards all of the other teams operating the station, and you simply don't have time for that anymore. You are the chief coordinator and representative of our team, so the increment lead doesn't take time on console. One other thing that's worth noting, and that I did list but not address in my slides, is the ASP role, which is the activity specialist, and that is typically a STRATOS who is an extra person in the room for very complex or time-consuming activities, so that STRATOS can focus on Columbus and all of the usual normal science activities, and we have the specialist STRATOS who's sitting in just to take care of one particularly demanding activity. And so sometimes when you have also ASPs to work, you may also work more than 90 hours on console in 1 month.
Okay, we have also one question from the Slido. Which part has the highest risk?
Sorry, which part?
Which part has the highest risk? This is the question from the Slido.
The question is a little bit vague in terms of what part means. But in a general sense, all of our systems have a certain degree of risk associated with them, but maybe I can take the more abstract approach first and talk about the station itself. The highest risk part of the station is actually the very back of the station, maybe counterintuitively because you think we might be flying into things, but the back of the station is where we normally dock the Progress rockets that come from Russia with resupply, and the stress of always docking, attaching to the same part of the station. We, of course, maneuver very carefully in space so that we don't ram into each other with a lot of force or speed, but of course there's always going to be something that is non-zero, non-negligible. And so the repeated stress of that, and also the fact that that is often how we reboost the station, we reaccelerate the station to keep it in orbit. Those repeated stresses mean that the back of the station is much more structurally unsound and more prone to, let's say, small leaks of atmosphere than other parts of the station. So that is, from the more abstract sense, of the highest risk in the ISS. I think it's also well documented if you read up about some of the stories associated with this. The back of the station where the Progress meets the station very often, that would be the highest risk area on the station. Within the Columbus subsystems, every system has its particular risk points. Electrical power is, of course, a fire hazard if you don't carefully control it and design things. By design, the station should be very safe. It should be very, very difficult to start an electrical fire, and generally it is designed in such a way that it will automatically shut itself down if there is anything out of the ordinary. And as a last line of defense, we have command either by the astronauts or by flight controllers like myself to make sure things are shut down. And if we lose control of a particular part that is causing problems, then we can always move farther up the hierarchy and remove power at a different level so that there is no power reaching that hardware anymore, no matter what level of malfunction we're experiencing there. With the environmental control system, there's also significant hazards with making sure that the station is well ventilated. We have to have good airflow to make sure that we can detect smoke in case of fire. And we also need to make sure that we have good air circulation, or there can be buildup of carbon dioxide and other toxins for the crew. So they are also carefully trained to keep an eye out for signs of carbon dioxide exposure, so that they can warn us if the ventilation in the cabin is perhaps not what it needs to be. But we are very careful, and everything is designed so that we shouldn't have any dead pockets in the module, and we should have good fresh air moving through the entire space, both inside of the racks and within the cabin space that the astronauts are occupying. And well, okay, I think that kind of covers some good examples, but every system has its key risks associated with it, and we could be here a long time. Like I say, it takes months, if not years, to train for this job. So we could talk about the risks and all of the different things that can happen for a long time. So I think that gives you already a big picture. Sorry, you're muted. I don't hear you. Still muted.
Okay, here is the question from Romuald Duret. How do you handle risk and continuous awareness during a full shift on console? Do you have breaks or anything like this?
We don't have any formal breaks during a shift when we're working on shift. There's a few ways that we manage this. First of all, you come prepared, you make sure you go to the bathroom in advance, you eat well before you go to work. But of course, it's still impossible to make sure that you won't have interruptions or need to take some time to rest, especially when you're working an extended shift or at night. It can be challenging to stay alert and aware. As a general rule of thumb, anytime that we don't have connection to the station, we are off duty. We are able to step away, go to the bathroom, make ourselves a cup of tea or get something to eat. Sometimes we have enough time to eat in the kitchens. Sometimes we just heat up something quickly and we bring it back and keep working. But it is a routine thing most of the time that there are interruptions in our connection to the station, both on S-band and KU. So we don't have a permanent connection to the station. We can get a critical link, so we can be prioritized for connection to the satellite network when really high priority operations are taking place, such as when astronauts are out on EVA. Then we will make sure that we are the first priority on the network and that we will have almost uninterrupted connection to the station. Unavoidably, there will always be short delays when the antennas have to switch from one satellite to another. So no matter what is happening, there will always be short interruptions, but those handovers, as we call them, between satellites generally last about 20 seconds. So that isn't really an opportunity to take a break. But we do routinely have LOS, loss of signal to the station, for a few minutes at a time, and on rare occasions, half an hour of LOS can happen, and we can have a real break during those times. But outside of LOS, we can ask the flight director for permission to leave the console to get something to eat or go to the bathroom. In general, that is at the flight director's discretion. So if they need us there working on something, they are also entitled to deny us permission to leave and to finish what we're doing first. But in general, we can take breaks as we need them. We are trusted with the responsibility of deciding when we need to be there and when we can take a moment away. So we're able to judge for ourselves when we need that space, when we need to take, say, 5 minutes to get some air and a quick walk. But in general, when we're assigned to a shift, we are on console as much as possible during that time. And actually, I think you also mentioned managing risk and remaining alert. In most shifts, that's not a problem. In extended shifts, and sometimes at the beginning of a morning shift or the late stages of a night shift, it can be difficult to remain alert and attentive. Thankfully, our systems are also designed in a way that it helps support us with that, both in terms of lights, sounds, the way that we lay out the information that is available to us and which ones we prioritize. So we have a lot of strategies to help make sure that even when we're tired or not at 100%, we still have a high level of situational awareness. We understand what's happening, and we will be very quickly made aware of anything that is a problem that we need to pay attention to.
Dennis is asking, how do you budget, schedule power and bandwidth resources?
Well, from the European perspective, this is actually a pretty easy job because that's NASA's job. We coordinate those resources with NASA. As I said, we receive all of the resources for Columbus, from power to air to data transmission, for the most part, from Node 2 of the US orbital segment. And that means that they have prime responsibility for those resources, and they delegate to us how much of it we're able to use and when. So we make requests and we coordinate with them for the resources that we need and when we're going to need them. And they can also deny those requests and dictate to us that we need to use less, especially for specific time periods, such as we may have station-wide power downs when vehicles are arriving or leaving the station, or during EVA to minimize the risk of any electrical hazards for crew, both inside and outside of the station at those times. Also, depending on where we are in the orbit, so if we have more or less solar irradiance, we may have more or less power available on the station, since the power comes from the solar arrays. So it is a prime responsibility for the NASA flight controllers. In this case, power is controlled by Spartan. Ethos is the position responsible for station atmosphere and environment. So they control also resources like the gases. And we have Cronus, who is the prime responsible from NASA for communications and for data. So we coordinate with those positions primarily for requesting the resources that we need to do the work that we're doing. But it's, as I say, a broad team across everybody. We're all trying to meet our goals, so they do their best to facilitate everything that we want to do, and there's very rarely an issue where we're asking for resources that they're not willing to give.
Okay, any other questions?
I see Dennis is writing inside of the Teams chat. Maybe I can fill the gap by discussing a little bit more about the other centers and other positions. Broadly speaking, we have two main points of contact as the European control team, which are MCCH, so that's the Mission Control Center Houston, based in the Johnson Space Center in Texas, and also POIC, which is the NASA center responsible for payload operations. And so we work with POIC for science-related things, and we work with MCCH for general station operations and resource management.
Okay, there is one more question coming from the Slido. How do you think about the future and ISS, and would your training be transferable to another projects such as Lunar Gateway?
Yes, yes. So let's address the first part of the question first. I am still optimistic about the future of space and the space sector. There will always be people who want to use it for questionable ends or activities. But by and large, people are still fascinated by the potential of space and the fact that it is still, relatively speaking, so unmarred by conflict and competition. And I am among the many people who is inspired by the history of collaboration and cooperation that we have in space to work together as one global community. And I think the ISS is the number one example of that, even through all of the recent havoc and politics that we've seen in the world. The ISS has been the symbol of international cooperation through everything, even between Americans and Russians, still working closely together and making sure that this international project is going off without a hitch. No matter what is happening down here on the ground, we are partners in space. Um, and as far as the transferability of these skills, we of course won't have exactly the same electrical system or life support system on Gateway as we do in Columbus. So the exact technical details will be different, but the overall skill set and training of what we are doing and why, and our understanding of the operational environment and the constraints that go with it, that is transferable to anything in space operations or any operational environment, really, that we have that capacity to think of all of the moving variables and to keep everything in mind and to prioritize, especially in moments of stress and urgency. It's worth noting also that the Human Exploration Control Center, or HEC, has been confirmed will be also based here in Munich. So when the Columbus Control Center is someday retired with the station, then all human exploration operations for Europe will actually be also supported and operated from here. So Gateway, Artemis, and all of the future projects that will come will be supported by these same flight controllers working from the same place.
Okay. Any more questions? Maybe I would use the space. Is your control center also able to serve as backup center for another modules, or this is open question?
Well, it is capable to be reconfigured to support any sort of environment that you may need. That's mostly a software barrier or a technological IT barrier of being connected to what you need to try and support or operate. So as a good example, there is one console set up in our control center for simulated support to the Luna, the lunar analog environment that has been built at the Astronaut Center for analog training and work with the astronauts and with the research teams that are based there. So we are able to also do flight control support to those simulated experiments that are conducted there. And likewise, if we needed to, say, refit our control center to operate a different part of the ISS or future station, as I say, we will be someday, maybe not in the so distant future, supporting gateway operations, and we will simply have new machines or new software configurations to enable us to do that from the same control center. As it is, we have two primary control rooms in the basement of the German Space Operations Center, and we also have an additional backup control room that is routinely used for our training simulations.
Thank you. I also saw Mustafa writing question. I don't know if he wants to ask something.
Maybe raise a hand or give a thumb if you want to simply voice the question, if it's easier that way.
We can unmute you.
Okay, we have a hand. I don't know if I'm also able to do the unmuting. permit. So, Jan, I think you should be able to unmute yourself.
Yes, I hope that you can hear me.
Yes, I can hear you.
First of all, thank you for the presentation. I was wondering, as a risk engineer, but in a completely different field, could you give some form of indication on how many anomalies or events occur in any given time frame that you have to take immediate action, let's say time frame of a year?
So we have a broad range of severity of events, as I'm sure you would imagine, and also frequency. So most often we have a high frequency of anomalies and malfunctions when we have new equipment that's only just being commissioned and tested out, and we work out the bugs. So sometimes when we have new hardware on station and new experiments, we can have multiple problems and anomalies arising every hour, really. You're finding a lot of things that don't work the way you expected, especially with the microgravity environment. And so there is, let's say, some growing pains and troubleshooting period. But it's really hard to put a fixed figure on it. Many days, many shifts go by without incident. But to give you a sense of it, we have a running history of major anomalies that needed documentation and investigation and reworking, which is running at a count of 4,096 as of today, since the beginning of Columbus in 2008. So that gives you some numbers to work with, but the frequency at which those occur varies quite wildly, and also the severity of those, of course. Minor malfunctions, such as data not going where it needs to, they happen all the time, and we fix those in real time. It's not a big deal. We have other things with payloads simply not able to perform the function that they need, and then we have major intervention to sometimes fix things.
Yeah, I see. Thank you.
No problem. We have a hand from Romuald.
Okay, I will unmute him.
Can you speak? If you're speaking, I don't hear you. Huh.
Well, I will try and disable and enable one more time. Maybe you can unmute yourself in the Teams. Maybe this would help. Right corner upper.
As a last resort, you can always write your question if it's not too long. Very strange, because I also have an option here to allow you to unmute, but okay, feel free to write it. I don't know if anyone else has something else that you'd like to ask, or if you still have any other questions that you want to maybe fill the space with, to give Romuald a moment to type.
Okay, let me think.
I can talk a little bit more about our training process and what goes into that. So when we arrive here, we are presented with a pretty overwhelming information overload. Of course, understanding how all of this job works isn't something that you're going to be able to absorb in a short amount of time. So every couple of weeks in the beginning of our training period, we will travel to the European Astronaut Center in Cologne for specific dedicated training courses that can also last a week or more, where we will have dedicated training on operations concepts, on the hardware that we're working with, on the systems. We also have a training called Human Behavior and Performance, where we're taught about psychology and teamwork and managing our own emotions, collaborating together to achieve the best outcomes and to understand how other people are thinking and working in their own spaces. So we have quite a few of these trainings in the early period of our training. Then we have a sim exam where our early theoretical studies are tested to prove that we are ready to start simulated training. Throughout the entire process, we're doing what is called OJTs, on the job training. So we will actually sit into a shift with a certified STRATOS and watch them work. And very quickly, we actually already do that work under their supervision. So we start with a handful of passive OJT shifts where we just watch what is happening and, learn by watching, but very quickly we're learning by doing. And we do active OJT shifts where we do all of the work with the guidance, supervision, and advice of a certified STRATOS who knows how to do this work for themselves. So it's very hands-on training, very practical. Then we get into simulations where we can start to see rapid fire anomalies and problems thrown our way to really put us to the test our resilience under pressure and when things are not going well. As well as our ability to maintain situational awareness under those circumstances, to maintain good communication with our partners, and to give the information that others need, and to ask others for the information that they have that we need to do our work. And that starts as an ESA-only simulation environment and builds to an integrated simulation environment with NASA and other international partners, where we work on different levels of problems together. And we need to understand what problems the NASA systems can have that affect us and which ones don't, as well as other international partners. We share some interfaces with JAXA as well, where we need to be aware that our cooling system affects theirs and vice versa. So there's a lot to learn, but it is very dynamic, very fast-paced, and very hands-on. All of that culminates in an ops examination where our final theory understanding and knowledge is tested to see that we are ready for taking on the full role of STRATOS, that our theoretical understanding has reached a sufficient level for that. And one of the last things that we typically do for STRATOS certification is we do a trip to MCCH. So we visit the Johnson Space Center and we do some on-the-job training with our NASA counterparts. We do some of the same training courses that astronauts do when they're newly selected. And we get a feel for how our partners work and what they're doing. And especially they give us some extra keen emergency training to make sure that we're really ready for the work.
Mm-hmm. There are two questions, well, actually three questions. Romuald Duret is asking, how much does EVA impact your work, your console work?
EVA?
Yes.
From a ESA perspective, EVAs have a limited impact on us. I mentioned earlier a little bit about how we often have station-wide power down conditions for EVA. So the impact there is largely to our science operators that they can't plan more than a very small amount of science operations during that period, and we have to prioritize. Our EPIC position will generally handle that coordination and planning of which experiments need to be prioritized, although that also happens at the increment level, so even higher again than just the planning team, but we have the overall administrative organization for the ISS program as a whole, and they will decide science priorities for a given increment. And so they will make decisions about which experiments will be allowed to run when we can't operate everything at the same time. And the biggest impact from a STRATOS perspective when we have EVA or robotic operations or visiting vehicles is that KA antenna that I mentioned earlier, our direct comlink, under EVA conditions or these other circumstances that I mentioned, we are generally not allowed to radiate from the station, or we need to minimize it and keep it carefully controlled to specific areas that are not allowed. So it is a significant workload sometimes for the STRATOS controllers to activate, deactivate, or control that antenna as needed. But for the most part, our ESA operations are not highly impacted by EVA.
Mm-hmm. Okay, there is a question from Bohdan. There should be a huge amount of telemetry and other data. Is there anything like applying of machine learning or data science to automate the process or predict something?
There are some projects in work to develop that and study it. There's currently nothing in use in operations, but one of my STRATOS colleagues is actively working on an AI flight control tool. It's a support tool, so it generally shouldn't be automating things. We already have a certain amount of automation built into the system, especially into the vital layer. As I mentioned, we have high-level computers on station that are responsible for automatic response to critical scenarios that we anticipate and that we're prepared for. And we have flight controllers for everything that we couldn't anticipate or prepare a pre-planned response for. But this AI support tool will be something that helps us to collect a large amount of information. So as I say, we already have and maintain a high level of situational awareness of what is happening in our module and on station and all of the telemetry that's available to us. But this AI tool is supposed to be able to better contextualize and collect that faster for us. So when lots of things come together to create one picture, we are fully capable of doing that work and understanding what's happening, but that AI is intended to make it faster so that it can see the same thing that we would see and simply tell us this is what's happening and this is what you need to do. So it's still going to be a flight controller responsibility, and the AI is there to help us to react faster and more effectively in those situations. But it also, considering the state of the technology, it's not something that we're likely to be willing to trust to work independently anytime soon. It's always going to be a support tool with a human deciding if it's right or not, and if we're going to act on the plans that it proposes.
And there is one more question. How do you deal with the large amount of responsibility and supposedly stress in your day-to-day work?
How do I deal with it? I come home and I don't sleep because of my baby. I mean, everyone has their own coping mechanisms. Personally, I come home to my family, I spend time with friends, I exercise, I read, I play video games, and that's just me and my preferences and the way that I spend my personal time and decompress. But I don't think that there's any universal answer to that kind of question. Everybody is their own person, has their own tastes and likes, and all of our brains work so differently. So I don't think it's possible to prescribe one way that will work for everybody. I could tell you more about what I do, but really, to some degree, it's a matter of trial and error and putting yourself in stressful situations, letting yourself face stressful work environments, and finding ways to manage under those conditions. So it's all part of the learning experience. I hope that was a good enough answer. I'm sorry if I don't have like a magic bullet for you to deal with stress.
Okay, maybe last chance for the question. Someone will add to the Slido or